Hello, today we are going to do the slopes to curved lines. So the first thing we have here, we have the graph of y equals x squared here. And to find any slope, you're going to need 2 points. You're going to need the first point that is going to be given to you on the graph, whether or not it's given to you. You're going to need 1 point on the graph you at least know 1 coordinate of, and then you're going to need another point very, very close to it in order to find the slope between the 2 points. So in this case, the slope is obviously equal to change of y over the change of x. So if you look at the picture here, we're given the point 2, 4, which fits into with our equation here. And to find the slope, we're going to have to do the change of y over the change of x. So to pick another point without using limits, because we're assuming you don't know limits yet, we will get to limits later, but if you don't know limits, you're just going to add a very small value. In this case, it would be 0.001 to each of the x and the y. So the points would be 2, 4, and then 2.001, 4.001. And this is how you're going to find the slope. Alright, so if you go here, the slope is equal to the change of y over change of x. So in this case, it's going to be change of y is relatively easy. You're going to have to plug in the x value into the equation here. In this equation, would be x squared. So the x value here, as you can see, is x and then x.001. So when you plug it in, it's going to be f of x plus 0.001 minus f of x. Then the change in the x value is going to be easily, you can see the 2.001 and the 2. So when we go over to the actual example here, we can see, say for this example, we're going to plug in 2, like for our example over there. So it's going to be, the y value is going to be, another way you can write this is f of 2.001 plus 2.001 minus f of x. But here we're plugging in numbers, so it's going to be f of 2 plus 0.001 minus 2. This is squared because according to our equation it's squared, and then over the change of x, the only change of x is going to be 2.001 minus 2. The change of x is obviously going to be 0.001. So we can easily find this is still going to be change of y over change of x, just like over there. So if we do the math here, we can find that the slope is actually equal to 4.001. So the slope in this case will actually be 4.001. Okay.
Let's use the method of adding 0.001 to our x values to find the slope. Now, an even more accurate way to do this is to use limits, because this way you're adding and finding a very close point and finding the slope between the very two close points. But here, if we add an infinitely small number, we're finding the slope between 2 points that are so close together that you're finding almost the exact slope. So in example, we have, let's say we're trying to find the slope at point x equals 3. So we're going to plug in x equals 3 for x, right? So we're going to do limit h approaching 0 for 3 plus h squared minus 3 squared all over h. H represents a very small number again. So we're adding this tiny number, and then we're to find the y values, and we're subtracting to find the y, change in y over change in x. So this is going to be the change in y right here, and this is going to be the change in x, the very small number h. So if we do the algebra out, that's going to be 9 plus 6h plus h squared minus 9 all over h if we just use the squaring. Then we can cross these out, these cancel out each other. So we get 6h plus h squared all over h. Now, the h we can cross out and cancel on both sides because it cancels out. And then we're left with the limit, h approaching 0 of 6 plus h. And because h is approaching 0, it's a tiny, tiny, tiny number, we can just cancel this out. This becomes 0. So the slope at this point is going to be 6 because of the h is just a tiny, tiny number. Great.
Okay. Here's another example of using limits to find the slope to or the tangent line or the slope of the curve. So for this example, we're given the graph f of x equals to x squared minus 3x. And then to use a visual aid, this isn't exactly the, if you graph this, you're not going to get this graph, but this is just for to kind of show you what's going on. We're given that at the point x equals 2. So this is the only value we actually know for sure is 2. But we can find all the rest of the values. So essentially, we have 2, and to find the x value of 2, we'll plug the 2 into here. So f of 2 is actually, this is the y. So then, and the distance for the infinitely small is exaggerated for seeing purposes, but the distance between the 2 points is h again in this case. So the x value here would be 2 plus h, and then the y value would just be f function of 2 plus h. Okay. So then if you look here in the actual graph here, for the actual limit, you can see f of 2 plus h minus f of 2 over h, because essentially the reason it's over h is because if you take the difference between 2 plus h minus 2 is obviously going to be equal to h there. So you can see that this represents, and this whole thing represents the slope, which is what we're trying to find, change vector over change y. And h, because we're doing, I keep saying x here, but this is supposed to be h. And because h is approaching 0, is infinitely close to 0, that's the distance between the 2 points is very, very small. Okay, so when we go over here, we're doing the algebra part of it. Alright, so now we still have the limit of h approaching 0. I apologize, these are supposed to be h's. And okay, so now it's time to take it on the top part, plug the f of 2 plus h into the actual equation, which you can see right here. So it would be 2 plus h squared minus 3 times 2 plus h minus 2 squared minus 3 times 2. And this is still all over h. So when we do a little bit, when we multiply it all out here, you can see we can cancel out the 4s, we can cancel out the 6s, and then we're left with limit of h approaching 0 still. 4h plus h squared minus 3h over h. So now we can cross out some h's here, cross out this h, there we go. And we're left with a limit of 4 minus 3 plus h. So because h is approaching 0, this is essentially going to be equal to 0, so we can just cross this out too as well. So we're given the limit of 4 minus 3, which is equal to 1. So the limit is equal to 1. That means that the slope is equal to 1, because because as you can see, this whole graph is a change of x over change of y, so the slope is also going to be equal to 1.
Okay, so now we're going to be moving on to log natural. And so we haven't learned a way to do this with limits in class yet, so we're going to have to do it using our adding 0.001 technique. So now we can do log natural of 1 minus log natural of 1.001 by adding 0.001, and then divide by the distance between the 2 points, which is 0.001. And if we put this into our calculator, we get 1. Now this is really the only way we really know how to do it. We haven't learned a algebraic way to do this. So this is the way we're going to have to do it. So now if we're looking for x equals 2, we can plug in again log natural of 2 minus log natural of 2.001 all over 0.001. And if we solve this out, we get 0.5. So if we do this again with 4, we can plug it in, divide again, and get 0.25. And finally with x equals 5, we plug it in, divide, and get 0.2. So what we see here is actually a recurring pattern in our answers, and we see that the slope of log natural of x is actually 1 divided by x. When we had 1, it was 1 over 1, so the slope was 1. When we had 2, it was 1 divided by 2, so the slope was 0.5. 4, 0.25, and 5.2. And so that's the conclusion we come to with log natural of x.
Okay, again, here we're talking some more about slopes, and this time we're talking a little bit more about manipulating slopes and how numbers can change slopes. So for the example, I'm using 2 examples, y equals e to the x and y equals sine x, just for a little bit of variety. So, I mean, as you can see, this is y of e to the x, and when we go over here, this is kind of changing what we're raising it to. So in this case, it would be y equals e to the 2x. So when we go over here, this graph right here is going to be y equals e to the 2x, and this is going to be the regular graph like over there, y equals x. And the reason the slope has changed is because by raising it to the 2x, it has essentially put 2 x's for every y. So it's really scrunched the graph. Makes the graph look as if it was scrunched, for lack of a better word. And therefore, it would be, the slope would be, because the slope here would obviously 1, because it's almost half again as I guess, scrunched, the slope would be 2 times 1, the slope would be 2. So then if we're using y equals e to the mx, the slope would be m times 1, and the slope would be m. Okay, and then down to the sine graph, these are very similar. When we go over here, we can see the original graph y equals sine x, and we know, like this one we knew the slope at the x-intercept was equal to 1. This one we know the slope at the origin right here is also equal to 1. So when we go to manipulate it a little bit, we have a couple different examples: 3 sine x, sine of 3x. So, for example, at the 3 sine x one, in this case, whereas this one we were kind of pushing it together because there's 2 x's for every y, this one we are kind of stretching it this way, stretching it vertically. So there's essentially 3 y's for every x. So it's making the graph look, again, it's more scrunched, for lack of a better word. And you can see again, compared to this graph right here, which is the sine graph, it has a much steeper slope to the factor that it was scrunched. So the slope is actually going to be equal to 3 because it was altered by a factor of 3, or it was extended by a factor of 3. So the slope is going to be equal to 3 times 1 to the x. So when we go down here, y equals 3x. This is essentially the same as this. It's going to be again. It's going to look as if it is shrunk horizontally, similar to this, and it's going to be very similar to this. It's going to have the same 3 times 1, 3 resulted by 3. So the slope's going to be 3 times 1. So it's also going to be 3. And then this is just a little bit of a thinker when you think about it. Just putting these two together. If you have the same graph here, like say you have 3 sine 1 over 3, or in this case m sine 1 over m times x. These two are going to cancel, and it's essentially just going to be your regular y equals sine of x. So there, a little bit of a summary of changing slopes by altering the equation just a little bit, multiplying, dividing, and raising them to different numbers, and there you go.